Back at it again? Oh. We got random color now. Line 7, missing argument. Oh, yeah. Sim environment and dot. There we go. Oh, yeah, I was right. Dot reset. Oh, yeah, argument. There you go. Nah, I should have run. That's correct. Stop yelling. Line 8's incorrect. What? Env is not defined. Oh, yeah, you're right. There we go. I made like 6 spelling chairs, dude. There we go. Okay. Alright. Random does work. Alright, so we need to do a physics engine here. Alright. Run it. Let's try to see what 0 do. Okay, so that puts them inside of one another. Let's just say 15. Yeah. to figure out what's that? I'm in Python sleep. I need an example block of x 15 times. Give me what are you doing? Okay, alright, gotcha. Alright, so range 15. That's not gonna be the correct argument. Um, that worked. Let's try this. There we go, that'll do it. Forget this. What is 4? Okay, 4. Oh, okay. Define. So what is this? 4n. I've never used 4n in my life. Not once. I'll break down just 4 in this loop. In this loop. 4 in this loop. 4 in this loop. What is four? Why is four? What do you mean four? Four item in iterable. Iterable. Okay. Why four in loop? Because there's no point. Efficiency is a four in? If that works, I'm gonna be pissed off. Let's just do in range. This is strange. Okay. Go to sleep. The blocks don't fall. I thought there would be physics to these blocks. Okay, so it works. All right, so why? Oh, okay. So that's. Well, how do I? One, two. Um. Um. You're overcomplicating it. One is the x coordinate. 0 is along the horizon, the right movement, and is 0 movement. Okay. Got it. So we'll just do this. We'll build it manually, like a boss. Alright, 015. Alright, there we go. Alright, run. Okay, okay. Aha, 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 aha. There it is. Oh, oops. There we go. Ugh, stupid me. $98,000. Okay. There we go. So that puts me at number 29 in the world on the I can make this better. I can do this better. I can do this better. Mm-hmm. 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 Thank you. I didn't want to type all that out. Alright, it's gonna go faster. That's all I need to do. Yes. Ooh, getting quicker. And that puts me at 19. We can do this even fast. Okay, we're gonna go even fast. We want to make this the fastest builder in the world, right? So to do that, .5. So it's 0.1. Might be it might be faster. Might be faster. 0.5 might be faster. $135. Okay, so it was quicker. And that puts me at 19. Puts me at 19. We can go faster. We can go faster. We can make it more okay. Let's do 4Z range here. Let's try to just get this code as small as possible. Dude, cat! Get out! Out! My gosh, my cat is gonna literally break stuff. Hold on. Wrong button. Dude. What? You can't do this. You can't do this. What are you doing? Get. Hold on. Get. Going. Go. Oh, yeah. Now. Okay, I'm back. Sorry. Golly. She was like, my gosh. Alright. Alright, sleep 0.5 on range 16, so I don't want to do 16, but I think Z starts 0.16. I think. Alright, we're up. I don't know, man. I don't know if I can get better than that. Let's try 0.1. Let's try 0.2. Yes. Gonna put me up to 150. I'm working my way to the top 10. That puts me at 10. 10 fastest in the world. Okay, I'm at 10 fastest in the world. Coding competitions, man. I tell you, they're always so intense. They're always so intense. Well, this is more of like an efficiency competition. It's not really a coding competition. It's a time, lock, memory, and CFD sent competition. Alright, so let's see here. How do I get this cleaner? Clean. Curate depths. Let's organize the code more. Reset. $16 lines. $151,000. Okay. 51,000. Good. Puts me at 9. Alright, I'm in the top 10. Top 10. Let's see. What did I change here? So my memory got like stuck. Was good. Alright, so if I put, let's say we just get rid of the classes. Rid of the classes, we get the memory back all the way up to, ooh, I'm top 1% in memory. Memory is good. So my lock, right? My lock is lacking. We need to unlock the lock. Unlock lock. My lock is great. My lock is shit. My bad. My memory might be bad too, actually. Okay, I beat 1% in memory. We're gonna do this. Alright, so it's gotta be faster. Let's get that better. Okay. Gave me about 94. Is less. It's gotta do better than that. It's worse. It's worse. It's worse. It's worse. 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 That's clean. Come on. Oh, that was fast as fuck. $106. Okay. Time lock memory CMDs. Time lock memory CMD sent. That's what we are graded on. Okay, let's see here. Oh, you moron. The time lock memory CMDs sent. You're not understanding. There's no need to code. Just understand the way we are ranked. Thank you. Write memory command sent. Right. Control the response to the event simulation. In summary, the ranking is likely to consider how well it performs in terms of efficiency. Yeah, exactly. Right. Time refers. Right. Okay. So now he understands the way we are graded. Good. Now, this is a top 10 score. Okay. He understands that this is a top 10 score. We need to improve it. So to improve it, he's going to suggest something trash. Wait, actually, no, hold on. Where the fuck are you? Oh. Stupid. Oh. Sorry. This is the right code. This is the top 10 score code. I sent you the wrong. Right. We need it to be even or right. Okay, what is your suggestion? Z equals print. Why? Well, no. See, you're adding a print statement. Okay. Print. This will add more CMDs. We don't want that. You're correct. Yes, I know I'm correct. All right, and accept and pass, right? And finally, we actually might be onto something here. I replaced the error printing with pass statement except block. This ensures that no additional commands are added, in this case error. But why? And call to function is build default parameters. So your call to functions, right, is to build the voxels with default parameters. So I mean, I don't know. This is numvox 16 delay 0.2 with the depth definity on the sub. Oh, yeah. Infinite loop. That's infinite loop. Okay. And then finally disconnects. And then that breaks out of the infinite loop. This could be genius, actually. But I don't know. It's quick. CMD speed 78%. Time is a Hondo. No. That was 146152. Yeah, no. That was 100K less score of the last one. I don't know. Well, actually, let's class it. Let's class it. I think we class it, and that's okay. Okay. I have an approach. Let's class it. Number of CMDs for the code you just sent me. No, count them out and tell me the fucking CMDs. Four. 35 commands sent. Shorten it. No, I mean literally adjust the code to get under 35 commands. Shorten it. Okay, what is this? After you send me a revision, tell me how many commands it sent. 34. Get it all the way down to 1. You're telling me that this is 1. You're telling me that this is 1. Exactly, you little bitch. Okay. I'm going to tell you how to get to 1. It's simple, okay? You want to make an entire one command class, and then that command does what we want all of those commands to do, and we call that class one time, and that's how we get to one command. Okay? Stupid idiot. He says, understood. Yes. That is one command. I'm a genius. All right, but wait, hold on. Hold on. He forgot something. I need to tell him that SimConnect and End need to be in this class as well. All right, because this is very important. This also needs to be included in the class itself. That's beautiful. It's absolutely beautiful. That is a masterpiece. Okay. Don't hit me with unsafe. Ah. Okay, so we have SimConnect and SimVoxel builders. Okay, then class voxel builder. Then a static method build voxels voxel 16 to laser. Okay. Try sim environment connect reset code false builder voxel. Builder box first. Ah. Yeah, you fucked up. Voxel builder, we're gonna change the class name to begin. And that should fix it. And then it is begin. And that should do it. I'm a genius. I'm a genius. Come on, show me some money. What? How is that less, dude? Come on, that's genius of me. Come on. CMD cent was beats 76%. These guys are freaks of nature, bro. What the fuck is Joda Lamp doing, man? Joda Lamp is like an alien, bro. Joda, what are you doing? What's your secret? I gotta beat hard. I beat hardcore earlier, and now, like, I can't. Where am I lacking? It can't be in CMD Sense 76. Memories, I beat 1% in my lock. Okay, so my memory is 1.6%. Alright, my memory score is that 1.6? That's trash, dude. 1.6. My time score is up to 153. It's actually really good. Wait. What can I... Wait, threading? Wait. I hold on. If I have threading unlocked, This isn't hash slips. I have threading unlocked. Okay. Let's use threading to help the memory. Now you did a class, right? Build voxels static on a def. Still considered the class should be called, what did I name it? Because it had to be different. Yeah, I had to name it begin. All right. Should be called begin because it's conflicting with other objects, and that's why. You need to remember to not name the class as an other object's function or you will create conflict. I can't believe you didn't understand this. You're absolutely correct. I know. Okay, so we have a thread here. He's created a revision, but I don't know if I like it. Voxel manager. I guess. You want to be politically correct? Sure. Let's be politically correct. Alright, so let's go ahead and paste that in there since you want to be politically correct. It should work. You fixed it. And give no. And still, anything starting with voxel is it's not happy with it. So oh, you fucked up, bro. Begin. Begin. That should work. No, I saw an error. No, yeah. Builder. Builder is build voxels, dude. You fucked up. No, that'll be begin. Anything else? Any other more voxel manager target begin? In should do it. I'm a genius. Error occurred type begin has no. Is he threading correctly here? Begin first is threaded. Create threads. Yeah. Here's an argument for builder 2z. Builder equal. Where's my builder equal, dude? Got it. Got it. Boxer builder will go begin. Alright, so okay. Ah, there you go. Type object begin has no attribute. Yes, it does. First. Ah, first. That's why. Gil. Because we're creating an object. Okay. That was close. Where in the freak? Okay. We did not include time. Yeah, you missed your time. We did not use time. Thank you. Should be time. We're gonna do time. What is it? Was it 1? No, it's a 0.2 after the after number of yeah. After the color random. Right, thank you. Time, and then there we go, 0.2, and that should fix that. I just didn't want to type all that, so use AI to type for you. You put the logic down. So now we've gotten to the point where we oh, you motherfucker, that's why. Okay, now no, jeez. 0.2. Wait, what's the other one? What was my other time? Yeah, 0.2. That's why it sucked. It didn't really dilate. Okay. We go. Okay. We go. Then. Okay. We go. Okay. Okay. Try. We go. 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 Elif. We go wait. No. We go wait as in it does it once, then does it again. Waits till it's done. Oh. Dilation. Okay, I know how to do that. I know how to do that. I got the logic here. This isn't gonna work. Again. Alright, no. No. Think with the brain. Think with the brain. We then try. Try then wait. Elip then try. Elip then try. No, that would be too much of a gap. What about if we went pause? Stop. Break. In this loop, we need to wait. We need to have finish and etc. Okay, that's what I need. No, that's not going to work. That's not going to work. No, it will put all, let's be specific here. At the same time, I want it to not. No, wait. I'm using threading lock. Synchronize the execution. Build voxels method. When creating, use threading lock to synchronize the execution. I don't want to. Wait. That actually might work, but in the PyJob environment, it's probably going to be scuffed. Yeah, it's scuffed. I was right. No, in the PyJob environment, it's wonky, dog. Now we introduced the Boolean flag named build to control whether the build voxels or not. Inside the infinite loop, if building loop building is true, it executes the voxel building process. Once that's set, building is to false to prevent the building again immediately. I don't know though if that's going to even be considered in the game. I don't think so. No, that's not logic in that dot object string. So again, where I am talking about, okay, where I am telling you to do, okay, which I'll be more specific, okay, on the def, okay, under here, all right, other than time in this, in the def loop, okay, 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 with an exclamation point. Let's get sassy because you're not listening, okay, all right, under this specific here, all right, an alternative to time 69 as the example. Okay. I understand you want to introduce an alternate mechanism to introduce a delay between the call build.voxels instead of using time.sleep within the loop. A way to achieve this is to add a delay between each call, however, can be implemented. Begin. All right, that's smart. That's actually smart. And that's really short, too. Oh, dude, oh, bro, I'm onto it. I'm onto it, dude. We were 4 off. 1, 2, 3. We need like, ooh, okay. Great, great. We need like 0.5 more a delay. Like, this is great. That's exactly. This is how I code, guys. I talk to this AI and me and our brains come together and I talk about arguments. I use all my coding experience and I just do it. So many people hate me for it and I do not give a shit. Here we go. Come on, show me something crazy. Did I just take 1, 1, 2, 3, 4, 5, 6? 1, 2, 3, 4, 5, 6. No. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 11,000. All right. Or sorry, 11. Ah, we're so close. We're so close. We're so close. That was beautiful. All right, that was beautiful. All right. All right. So show me the string where it's like timer threading time 0.5. So it's under timer threading. Oh, why not use it? Delay. Begin delayed build. Where is delayed build? Begin delayed build. Where did you classify begin delayed build? Begin delayed build is where? What is it, just a threading? Def is builder Z. Oh, that's crazy. That's the most fucking deceptive thing I've ever seen in a code. I am impressed. That's crazy. Def begin build. Just the def itself on the static method is literally creating a delay. But how did he do that? How did he go from where did you define that? Let me ask him. Where did you define this? Oh, sorry, I need to be more specific. Begin build. What's causing the delay? I'm confused. How did he do that? Did he really time it? Let's listen
I
to him.
apologize for the confusion. It seems there's a misunderstanding. In the provided code, the delay is caused by the use of the threading.timer function. Let me explain. In the build voxels method, a loop iterates through the range of num voxels, and for each iteration, a threading.timer object is created. The threading.timer object schedules the delayed build function, which in turn calls the build voxel method to be executed after a certain delay. The delay is calculated as 0.5 z, where z represents the index of the current voxel being processed in the loop. Therefore, the delay increases with each iteration of the loop. For example, for the first voxel, when z is 0, the delay is 0 seconds. For the second voxel, when z is 1, the delay is 0.5 seconds. For the third voxel, when z is 2,
That's insane.
and so on. This delay mechanism allows for a staggered execution.
You made the most complicated delay vexel or method I've ever seen.
Using the threading.timer function to schedule the execution of the delayed build function.
Wait, never mind. Eat my words. Threading.timer.
This clears up any confusion. Let me know if you need further clarification.
Yeah. I need you to clarify threading.timer. Clarify the usage of threading.timer. I thought you just literally went off raw binary and just literally made a delay based off of, like, you just knew the time between these commands. Like, fuck. There's no way. Alright, thank you. Alright, so it's just something I didn't even know that was in threading. I use threading all the time, learn something new every day.
The threading.timer class in Python is used to schedule a function to be called after a specified delay. It's particularly useful when you need to introduce a delay without blocking the execution of your program. Here's a breakdown of how threading.timer works. 1. Initialization. To create a timer, you instantiate the threading.timer class with two parameters: interval, the delay before the function is called, and function, the function to be called after the delay. Python timer equals threading.timer interval function.
Okay.
2. Starting the timer. After creating the timer object, you start it by calling the start method. This begins the countdown for the specified delay. Python timer.start. 3. Cancellation optional. You can cancel the timer before it expires by calling the cancel method. This stops the function from being called if it hasn't already. Python timer.cancel. 4. Function execution. Once the specified delay interval elapses, the timer calls the specified function. The function is executed in a separate thread from the main thread, allowing the main thread to continue executing other tasks without waiting for the timer to expire. Here's a simple example demonstrating the usage of threading.timer. Python import threading import time function to be called after a delay, def my function print function executed. Create a timer with a 5-second delay timer equals threading.timer of my function. Start the timer, timer.start, wait for the timer to complete, timer.join, print end of program. In this example, the function myFunction is scheduled to be called after a delay of 5 seconds using threading.timer. The program continues executing other tasks after starting the timer without waiting for the delay to expire. When the delay elapses, the function is executed and the program proceeds.
Okay, so you implemented this in... Right. So what we need to do, each block, or sorry, each builder needs to build and finish so allow the other no, that's it. With that logic. No, it's the disconnect. When all are finished. Let me confirm that. So all right, and run. Okay. No. The builder needs to build all of them at the same time with threading, allowing them to do it at the same time. I'll read what he says before I use it.
I see you want all the builders to start building their respective voxels simultaneously. We can achieve this by using threading to create and start a separate thread for each builder. Here's how you can modify the code to accomplish that. Python from PyJob import sheet import random import threading class begin at static method def build voxel builder z builder
Yes.
build voxel 0z colors.random at static method def build voxels num voxels equals 16 try simenv.connect nv equals simenmanager.first nv.reset stop coding false builders equals voxelbuilder.first for score in range num voxels create a list of builders create and start a separate thread for each builder threads equal threading.thread it equals begin.buildvoxel args equals
It's a lot of memory.
for z in range num voxels for thread and threads thread.start wait for all threads to complete for thread and threads thread.join simen.disconnect accept action as e printf an error occurred e call the method to build voxels begin.build voxels In this
Okay.
modified version, we create a list builders containing instances of voxel builder, one for each voxel to be built. We then create a list of threads where each thread is responsible for calling the build voxel method for a specific builder. After creating all the threads, we start them using the start method. Finally, we wait for all threads to complete using the join method to ensure that all voxels are built before proceeding.
And then that would be builder's box or builder first for in range non-voxels. Threading target begin build voxels args are yeah, that's pretty good, but is it good enough to beat? I mean, the PyJop environment, so slimy. So slimy. I'm gonna unlock. All right. Use the restroom. All right, so I'm back. More voxels here. The threads are not working. Completing. My internet just go out. The stream is up. Whatever. Hello? Being DDoSed? What's going on? The website went down? Just see.
System, the application.
Let me just see if we can.
How to get the most of Grammarly free.
It's Kayla on behalf of Grammarly to tell you all.
What is going on, guys? Welcome. In order to work, accuracy goes down the less.
What is going on, guys? Welcome back. In this video today, we're going to learn how to do live face recognition using Python. So let us get right into it. And when we hold our faces into the camera, we want the system, the application, to recognize that it's us. And if someone else holds their face into the camera, we want to see no match. So we want to see a match when it's us, and we want to see no match if it's someone else or if there is no face. That's the basic idea of this program today. And of course, then you can use that or try to use that for authentication purposes, probably not too intelligent, or for some notification system that recognizes people and then triggers a notification or triggers a certain function, whatever. Whatever you want to do with that is up to you, but this is what we're going to build today, a live face recognition system in Python. And for this, we're going to need two things up front. First of all, we're going to have to install two external Python packages. And second of all, you're going to need a reference image. You need an image that is basically showing you that you can use to do a matching, because of course you're going to get a face from the current camera image and you want to compare it to a reference image and see if that's the same person. So in my case, I recorded one before the video. This is my reference image here. You can just
He went all fuck boy, dude.
Use the program to match yourself with that image. So I have this here stored in the same directory as my Python file with the name reference.jpg.
Yes.
So for the libraries, what we're going to do, or for the packages, what we're going to do is we're going to open up the command line and we're going to type pip install, and we're going to install opencv-python, and we're also going to install deepface. So opencv python is going to be used for the camera, so for interacting with the camera, processing the camera frames, and deepface will be the machine learning model, the deep neural network behind the scenes. And we're going to start in our code by importing the core Python module threading, and then we're going to also import cv2, which is opencv, and from deepface, we're going to import deepface in title case, or Pascal case, probably. So those are the imports. Now, what we want to do first is we want to have this basic OpenCV camera structure. So we want to define a video capture, we want to define a camera, we want to set the properties, so we want to set the width, the height, and then we want to go through this endless loop until we terminate it that just gets the frame and does something with it. So what we want to do first is we want to define a capture object being equal to cv2.videoCapture, and here we need to specify the first parameter, which indicates which camera you want to use. So if you only have one camera, you have to pass 0 here, because video capture 0 picks the first camera. And if you have multiple cameras, you can try 0, 1, 2, depending on how many cameras you have.
Correct.
One of the other cameras. We're also going to provide here cv2 dot cap underscore d show. And then we're going to set the properties that I mentioned. So we're going to say cap dot set cv2 dot cap underscore prop underscore frame width. And we're going to set this to 640. And the height is going to be set to 480. So we're going to keep it small and simple here. And then what we want to do is we want to have, in addition to that loop, we want to have some other variables that we're going to keep track of, because of course we don't want to verify the faces. We don't want to look for a match every single frame. We want to do that once in a while, because if you do it all the time, first of all, matching the faces, determining if there is a match or not using this neural network behind the scenes will take more than just half a second. So we're going to have to wait for the response, and we don't want to start a new response with every single frame, especially if you have 30 to 60 frames a second. You want to do it once in a while, and we're going to do that by using a counter variable. And when we have a certain amount, so we're going to take this modulo 30, for example, or modulo something else, and then once in a while we're going to check this. So counter is going to be 0. Then we're also going to say if there is a match or not. This is going to be stored in a Boolean, because this Boolean will be globally accessible, and it's going to be determined by something running in a separate thread, but it's also going to be used by the main thread. So we're going to define it up here.
Yeah.
And then we're going to load the reference image. So reference image is going to be equal to cv2.imread reference.jpg. Reference.jpg, there you go. And then we can basically do our main loop. So we're going to say while true, we're going to get the return value and the frame from camera read. So capture.read. This returns 2 items, the return value. So we use the return value to determine if there is something, if it did return something, and we use the frame to get the actual frame that it returned if there is a return value. So what we do is we say if there is a return value, do something. So we're going to just pass here, and what we want to do with every iteration is we want to get a key. So we want to say cv2.waitKey 1 to get basically to be able to process user input. So if I press a key, it should be recognized, and if this key that I press is equal to the ordinal of q, so if I press q basically, then we're going to break out of the loop, and when we're out of the loop, we want to say cv2 destroy all windows. That's the basic structure, and all the magic is going to be happening here inside of this if return value exists block. And what we want to do here is, first of all, let's just go ahead and display the result. So, or not the result, but the actual image. So cv2 dot, or actually it doesn't make sense. Since I'm recording, I'm not going to be able to access the camera. So I'm going to have to write the full code, and then once we're done, I'm going to have to turn off this camera that I'm recording with right now to be able to use it in Python. So it doesn't make sense to do any steps in between here. So let's go into the actual code directly. Let's say the counter has to be, and now we can choose a number that works for you. Let's go with 30. Every 30 iterations, we're going to do the following thing. So if modulo 30 equals 0, we're going to do the following thing. We're going to try to start a new thread that is going to run a specific function, which is going to compare the frame that we have from the camera with the reference image. So we're going to say threading.thread. The target function will be something that we don't specify yet, that we don't have yet. So I'm not sure if I can do pass. Let me just define the function without writing any of the code. So I'm going to say here, the function will be called checkFace, and it's going to take a frame as a parameter. I'm going to pass for now. So this function checkFace will be run in a new thread. So we're going to say checkFace is the target. The arguments are going to be the frame. So I'm going to pass to that function a copy of the current frame. Now what's important here with the arguments is, since we're passing a tuple, the arguments is always a tuple here. So what we want to do is we want to add a comma. Even though we don't have a second argument here, we need to add a comma. Otherwise, it's
lazy
one element surrounded by parentheses. Python is not going to turn this into a tuple, but args is a tuple, so we need to pass it as a tuple by adding this comma here. So we have the arguments. And then we want to just start this thread.
That
So with the
pisses
Python
me
stuff,
off.
we started, and this is our try block. If for some reason this does not work, so if we get a value error, which we're going to get quite often because it's not going to recognize a face. The problem with deep face is that when it does not recognize a face, it doesn't just
If
tell you that it
print.
doesn't recognize a face and it returns a no match. It tells you, it doesn't tell you anything. It just throws a value error. So if it doesn't recognize a face in an
If
image,
value
it's a value
error print.
you're not going to be able to do anything. So we're going to catch that.
If value error
Just
print.
pass. If it doesn't recognize a face, it doesn't recognize a face. We don't care. It's just not.
Ghetto.
We're going to also say counter plus equals 1 every time if there is a return value. And then we're going to do the following. The face match boolean that we define up here will be changed by that function depending on whether there is a match or not. So we're going to assume that the work here has already been done properly. We already checked the face, so we already have the comparison and the result. So what we want to do here is we want to say if there is a face match, we want to put a text onto the image. So I want to say put text onto the frame, and the text is going to be match. And we're going to pass here. Now I'm not sure what the actual, oh, it's displayed here. So first we're going to say 2450 to define the position. Then we're going to define the font, which is going to be CV2 font underscore Hershey simplex. Then the scale of the font is going to be 2. The color is going to be red because we have no match. So we're going to say, or actually, no, sorry, this is match. So it's
Green.
green. So it's going to be the center value. It's going to be RGB, or actually in CV2 it's BGR, so blue, green, red, which means
Fuck.
0,
R.
255, 0 is going to be green. So we have 255 for the green value, 0 and 0 for red and blue. And then we're going to, I don't know actually what the last parameter was. Does it show that in the function signature? It was the thickness. There you go. The thickness is going to be 3. So this is what we specify here. Otherwise, if that's not the case, we're going to copy that. We're going to paste it down below. We're going to change this to no match, and we're going to change the color to 00255. Remember, BGR, not RGB. So the R is here. We set red to 2.
Why would they do that?
Meaning we're adding this red text. And of course, every time we want to also show the result.
Oh, they would because it would conflict with RGB.
Have on this frame. So the camera
Got it.
and our detection or not. And of course, we need to provide a title. So let's just call this video. And this shows the result. Now, everything's done other than the actual checking. So the actual machine learning here. Which is going to be done with deep face. So what we want to do here is, first of all, I want to say that face match is a global variable or a global object, and we want to say try to do something. If it fails, if we get a value error here, again, we're going to just pass. And here what we're going to try is we're going to say if deepface dot verify, and we're going to verify the current frame that was passed and a copy of the reference image. The reason I pass a copy is I'm not sure if that's even necessary, but I think if we don't pass a copy, we're actually using the object, and I'm not sure if it could lead to some locking situation for the respective threads because we run a new thread every time. So maybe if the actual object is being used, we're going to have some problems. I'm not sure if that's the case, but just for safety, I use frame copy and I use reference image copy. And then what we want to get here is actually the verified, because the verified is going to be either true or false. It's going to be it's going to be either true or false, and if it's true, we are just going to set face match equal to true. And otherwise, actually, why is that a problem? Image path to unfilled.
Yeah, because you close your loop.
Why did I pass a list here? This is how you do it without the
There
square
you go.
brackets. So the face match is going to be true. Otherwise, it's going to be false. And that should actually be all of the implementation. So let's go through the code quickly again. We define a camera object. We set the proportions, the dimensions. We initialize the counter being 0. We set face match equal to false. we load the reference image. We have this function that verifies, that checks if the reference image and the current frame have the same face on them. And this happens before we put some text onto it. So we get the frame here from the camera without having any text on it. We put a copy of the frame. We pass a copy of the frame to the check face function.
Yeah.
We get the result. Depending on the result, we say there is a match, there is no match. This changes this variable here. And here what we do is we say, okay, if there is a match, we write in green color match onto the image, and otherwise in red color no match.
Simple.
That's basically the idea. Now I'm going to turn off this camera and we're going to look if this works. Now before we move on, I found two little mistakes. First of all, I have a typo here. It's verified, not verified. And also we need to set face match equal to false in the case of an exception, because obviously if it doesn't
Or just fix your...
also set face match to false. Otherwise it's only going to be false if we see a face that's a valid face, but it's not us. So we're going to set face match equal to false. All right, now here we are. I'm holding something into the camera to prevent it from seeing my face. I had to start the application before I could start OBS because otherwise it would recognize my camera. But this is now the program running. You can see no match because there is no face to detect. And now if I remove this, we can see if it can recognize my face as the face in the reference image. So there you go. There you go. We have a match. If I move into the camera, we have a match. Probably if I turn around enough, we have no match anymore. If I then look into the camera again, we have a match. If I put this in front of my face, we have no match.
It's fucking cool.
So this works, and I also tried it actually with someone else. So I put them in front of the camera and it said no match because it was not my face. But of course, if I have someone who looks very similar to me, maybe some look-alike, maybe some brother or something, even though I don't have a brother, but this would probably not work perfectly. So you could definitely fool this system into believing that it's you. And of course, you can just hold an image of another person into the camera and would not detect that it's not that person, but just an image, because this is not something that goes into your biology. This is just an image detection. But it seems to work quite well. Of course, if I move around, or not around, if I move away, maybe it's not going to recognize me anymore. But essentially, this works most of the time. So this is how you build a
I'd say it's pretty good.
system in Python. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future.
I actually like this guy. He makes a little mistakes, but I like him. I like him. He's really cool. He really does some really futuristic shit. Development dockers and blueprints and automatically fill PDF files. Search engines in Python. I like this guy. Neural 9. Okay. We're building a tiny house. What the fuck? Get. This data center shit is weird. I don't get it. I don't get its functions. Voxel target. Okay, there we go. Okay. I did it. Alright, you see it printed a voxel target. Alright, I get it now. That's simple. Now we're gonna check object here. Objects and reset. Say environment. Base equal. We'll say env equals sim environment manager dot first. And then we're gonna say n, or no. Class will be n environment. Step 2 will be then environment. Reset. I always forget this place. Stop. So. Yeah, it'll be reset and stop. Stop code false. Right. So then we say is sim environment equals sim manager environment reset stop code false. Yep. All right. Object will reset here. Reset stop here, and then we need to grab the object that equal data exchange. Before we do that though, because we want this to restart, we want this to grab that equal data exchange first. For memory leak errors. Right. And so objects and restart. Build. One more thing. We need to grab the vortex builder. So it'll be vortex builder find.stacker. Its reference to is builder. So we make sure that our equal to is builder. Builder equal first. Code. Right. So we have data exchange. Oh, boom. And we're gonna get rid of sleep. We're not building. Yeah. Oh, builder equal vortex first. Right? Right. Builder equal vortex first. Vortex builder first. And then we're gonna get rid of this because we don't need to build. Right. Command will then be get data. Right? Get data. So we need to get to a database exchange dot find data, and that will get us data exchange first. And data exchange dot first done. And we need to get data. And that's it. Get data. And our second code we have placed in the placeholder print, which was a vortex target. Right. So we needed that print that from that get data in vortex data. Data from that set data. Oh. What we'll need to do is build vortex data builder /d z. We need to get rid of that. And what we'll need to do is we'll need to create a class. I'll go build the vortex. But I need one more build example here. So let's just go down here. One more build example because I did not. Alright, from right here on 15, we're gonna paste that. So it says here build vortex and then the number. So a builder build vortex. And then we'll go def data here. Builder build vortex. I'm gonna replace this. And I'm gonna copy this, paste this here. I'm gonna keep that there just in case I need to use it as a reference one more time. Builder.build underscore vortex. And in that build vortex, we're going to build the vortex builder or the data exchange specific target. Target vortex. We need to build target vortex. And it'll be colors random. I believe this should work. Oh yeah, I need to set the class to get target vortex. Get data. Or not class, sorry, I need to set the function to get data. So we can call to the class later on. And that would be a dat.set data. And we might not need the print statement. We might, depending on the PyJob environment. So underneath there, get data, dat number.5.6. Believe that should work. I'm going to get rid of the class. And I'm going to just call to it. Alright, so it says line 10, this is not callable to... Oh. Yeah, oopsie doopsie. There we go. There, now. You should fail again. Okay, but we were able to take... Alright, so we got it. It built the target vortex that we wanted. So instead, we want to get data target vortex. So we say get data with say, let's just say get data. Doesn't like that. Let's just say dat. Dat. No, we say dat. Get data. Let's say dat target. Okay, let's say gotten data. let's say set data. I don't know what a call to set data is. Oops. Let's try. How do I call to voxel target? How do I call to that? We have a set data, which is the ID box. Remove data. We have make a remote procedure call. What? What is this actuator, man? Like, what did... He needs to explain the functions of this thing.
Let's build a tiny structure as which color. In this case, you if I don't know, you need a numpy for this level. You just see we have a for the last dimension. Now what you can now do is assign this to 3 variables in range y and z. Can be a little tricky, so let's just check if it's larger than 0. And if it is,
No, I don't want to do that, okay? What I want to do is I want to understand your data. Or thingy, guy. I can code this myself. I just want to know what you mean by voxel target and how do I get that object. There's got to be a way to do that. Vox shape x, y, and z equal box shape box equal array. Data exchange first get data. That's the only way to do it? I have to array all of your print statements? Really? There gotta be another way.
y and z, and then continue to the next part. So we will check if the voxel data at position x, y, z equals 1. Then it works in this case, but it's when checking floats, it's always better to do something like this. So if it's not 0, if it's greater than 0, it should be 1, but floating point arithmetic can be a little tricky. So let's just check if it's larger than 0. And if it is, then we take our builder, our voxel builder, and build a voxel at the appropriate position. This one takes 3 arguments. The position where you want to spawn the voxel, so a small solid cube. The color of the cube, this is free in this level, you can choose the color as you like. and whether physics should be simulated or not. Now, if we want to be sure that the blocks stay in place, we should not simulate physics so that they are not affected by gravity. Otherwise, this house could, well, collapse. All right, so the position is simply x, y, z. So this is the position in meters. So the level is designed this way that if you use the coordinates like this, it will, well, spawn at the correct location. You could, of course, move the house somewhere else. You could subtract some coordinate here and move it somewhere else. Or you could, instead of building it on the ground, you could also build it up in the air, move it up. This would work as well. Now, color is free. We've freely chosen. Let's take red. And do not simulate physics. Okay, this should be everything we need. So we do not need a while loop here. We simply need to build this structure once. We need to read the data once, understand it, iterate it, and build. No reason to have any dynamics in this code. So let's run it and see if it works out. One thing is missing here. It here. And let's have a look at the code to see how you can achieve this. I prepared some code, but we will write the remaining part together. First, you do need a NumPy for this level. So if you have not unlocked it from the perks menu, please do so, because the data in the data exchange, this voxel target, the data cube that you saw just a second ago, is a three-dimensional list. You can work just with this list, but it gets a little easier if you do it with NumPy. Now NumPy converts this list into a three-dimensional static array, and we can iterate through this array to find the non-zero entries. So if we just run the code as it is now, so it doesn't do anything, it just prints the shape of the data, meaning the dimensions of this cube. And we see we have a cube or a grid of 6 by 5 by 3 entries. So this is the size of the data we are working with. So all the coordinates we will find should then be, well, between 0 and 5 for the first dimension, 0 and 4 for the second dimension, and 0 and 2 for the last dimension. Now, what you can now do is assign this to 3 variables. It makes it a little easier to work with those.
What?
Now, what you can now do is assign this to 3 variables, 0 and 5 for the first dimension, 0 and 4 for the second dimension, and 0 and 2 for the last dimension. Now, what you can...
So I did this completely wrong. Completely wrong. So this is a build. Vox MP S array. Vox. What the fuck is MP? Could you explain that? Because you're not explaining this, and I just want to know what this is. I don't care about the logic on how to do it. I can figure it out. I just need to know what the fuck is this data exchange, man? What is this thing? All right. Builder equal Vox builder first. Vox equal MP. Yeah, this is what I'm saying. Oh, oh. He says, is MP something that you assigned higher up in your code? And I try to use this command, it shows MP is not defined. But you're not asking the right question, dog. You're asking if MP is... I want to know what the fuck MP is, man. Let me just type in what he has. As array. What the fuck is MP? Get data. Oh, I see, I see. And then it's gonna print the voxel shape. Why can't he just set it to MP as right. Right. What? What the fuck, bro? What? That's so complicated. Like, what the fuck? Well, can I just do this? Oh. 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 Okay. Okay. It's not complicated. It's just vox dot shape, right? Right. So we are gonna print get data and then print that as vox shape. All right. So then we print the target data. Then we just print dat dat dot shape. Not blue. No, it is blue. And shape is okay. So it should work. I can get rid of this. It's gonna fail, but I just want to see it print that dimensions. No, it says set data. That shape. Is he? Ew. Vox equal vortex. Data exchange. So it would be dat equal MP. Oh, wow. Okay. Oh, I get it now. Okay, so dat would then be dat first dot get data. All right, because we only want to get one thing here. Dot get data. Get data target. Understanding this fucking object is like it's an alien object that I have to learn. And then vox target, voxel target. Voxel target. This is a puzzle game for programming, guys. All right. So then we print the vox shape. Oh, then we print the. Right, then it takes that, and then it prints the. And then we're gonna print the. Print. Would be dat. Would we print, what is that? Print. Print dat. Dot shape. Yeah, I did it. So now we've just been specific. And get rid of, we'll just copy this, delete it, and we'll just test this. It has no attribute, bro. What the fuck do you mean? I'm doing what you asked. What the fuck is MP? Oh, it's NumPy. It's NumPy. Oh. Okay. Okay, alright. Now that I know what the fuck I'm looking at, NumPy, okay, alright. NumPy works off of the data exchange. I get it. It has to. Like, he's literally saying it, you, like, it has to. Like, you have no choice, son. NumPy is your life. So, in that case, data equal NumPy. NumPy as array. So what I want to do is I want to say explain as array in MP. All right. So I want to learn that real quick because I've never used arrays in NumPy.
In NumPy, np.asArray is a function that converts input data into an array. It attempts to convert input arguments to arrays, but does not copy if the input is already an array. This function is particularly useful when you want to ensure that a given input is represented as a NumPy array, regardless of its original data type or format. Here's the basic syntax of np.asArray. Python numpy.asArray dtype equals none, order gets none. A, the input data, which can be an array-like object such as a list, tuple, or another array, or a scalar value. Dtype, optional, the desired data type of the output array. If not specified, NumPy will infer the data type from the input data. Order, optional, specifies the memory layout of the output array. This can be either C for C-style row major order default, or F for Fortran style column major order. Here are some key points about np.asArray. 1. Array-like input. np.asArray accepts a variety of array-like input types, including lists, tuples, and other arrays. It can also handle scalar values, which are converted into zero-dimensional arrays. 2. No copying. If the input data is already a NumPy array, np.asArray returns a view of the original array rather than creating a copy. This means that modifications to the output array will affect the original array. 3. Data type inference. If the dtype parameter is not specified, NumPy will infer the data type of the output array based on the input data. If the input data contains elements of different types, NumPy will attempt to find a common data type that can represent all the elements. 4. Memory layout. The order parameter allows you to specify the memory layout of the output array. By default, order equals C. NumPy creates arrays in C-style row major order. You can also specify order equals F for Fortran style column major order. Here's an example demonstrating the usage of np.asArray. Python import NumPy as np. Convert a list to a NumPy array, rr1 equals 1, 2, 3, 4, 5, npr1 equals np.asArray rr1, print npr1. Convert a tuple to a NumPy array with specified data type, which equals 1, 5, 2, 1, 2, 5, 3, 5, npr2 equals np.asArray r2, dtype.float2, print np. Ensure a scalar value is represented as a NumPy array, scalar equals 10, np scalar equals np.asArray scalar, print np scalar. In this example, np.asArray is used to convert a list, a tuple, and a scalar value into NumPy arrays. The resulting arrays are printed to demonstrate their contents and data types.
Okay. Yeah, yeah. So he puts this into an MP as array. As an array. As array. So MP dot array. MP dot as array default to what type of an array? Um, um, A D or order okay. So as array is A. Let's say yes, no. Yes, as an array is a function provided MP as array is an A type array. Yes or what? The dots of all MP type of arrays. These error D type, error float, error D type, error complex D type. Okay, and for A. Shit. That converts input data as a number. Alright, so if so I could just say voxel target. Alright. An example. So as God damn it, ChatGTP, fucking stop going down. Trying to learn something right now. Sure, here's some examples of MP. Okay. There's your data list equal your array. Print, alright. Got it. Alright, I understand it now. Vox equal MP dot MP dot as an array. Data exchange. Okay, So he's turning MP, he's turning the data exchange, get data, vortex data into an array, and he wants to print the Vox shape. That's very specific to its function. So import numpy as MP for every single thing is an array. Data must be transferred as an array. That data exchange dot first get data works the data print. Sorry. Dat equals MP space as an array. As array. And quote. Close it. And print the data shape. Alright, so he explained the shape is 653. Alright, so what I don't understand is how he's identifying that. I'm going to use the restroom and then I'm going to figure out what he does with the specific shape. So this exact thing just pukes shapes out, and I need to understand how to deal with them mathematically. All right, back I am. All right. So, sorry to keep y'all waiting. All right, so let's go.
Now do is assign this to 3 variables. It makes it a little easier to work with those. So these 3 variables tell you exactly these numbers, 6, 5, and 3. And now we can iterate over those. So for small x, these numbers, it makes it a... Now what you can now by 3 entries. So if we just run the code as it is now,
I just want to understand what this shape is.
prints the shape of the data,
Yeah.
meaning the dimensions of this cube. And we see we have a cube or a grid of 6 by 5 by 3 entries. So this is the size of the data we are working with. So all the coordinates we will find should then be, well, between 0 and 5 for the first dimension, 0 and 4 for the second dimension, and 0 and 2 for the last dimension.
Okay.
Now what you can now do...
It's coming together now. Because 0 is not, it does not count. It does not count. Wow. Right, so what is wrong with his array? It pisses me off, though. How he does this math.
Assign this to 3 variables. It makes it a little easier to work with those. So these 3 variables tell you...
Right. So let's do that now. All right, so... X, Y, and Z. Equal that dot shape. Right, because he's using box, I'm using that.
Exactly these numbers, 6, 5, and 3.
All right.
Now we can iterate over those. So for small x in range big X, and then for small y in range large Y, and for small z in range large Z. Now
Okay, I get that. Yeah, that makes sense because you would have you'd have a collision. So that's smart. That's a bitch. Numpy's a bitch for that. Alright, so we would say 4, 4, and 4. So of course, small x is it in range large X. Next, for small y in range large Y. For small z and range large Z. Alright.
We will iterate every entry in the cube, in this data cube that we have. And now we will check, is the entry at this position 0 or 1? If it's 0,
Right.
then we will spawn a little block at the specified location. We now know the location X, Y, and Z.
If it's above 0.
Continue to the next part.
Yeah, so if it's above 0, it will hit that.
We will check if
Right, if.
the voxel data at position X, Y, Z
Yeah.
equals 1. Then
Greater than 0.
it works in this case, but it's when checking floats, it's always better to do something like this. So if it's not 0, or if it's greater than 0, it should be 1, but floating point arithmetic can be a little tricky. So let's just check if it's larger than 0. And if it is, then we take our builder, our voxel builder, and build a voxel at the appropriate position. This one takes 3 arguments: the position where you want to spawn the voxel, a small solid cube, the color of the cube, this is free in this level, you can choose the color as you like, and whether physics should be simulated or not.
Okay, so yeah, so he's created his array here. This is his array. Greater than 0. I mean, that's simple. I mean, I guess. Right. So, if vox, so it'd be if dat. Right, so if dat is X, Y, or Z. X, Y, and Z. Then greater than 0. Then we builder dot. We builder dot. Way that he. Right, so we builder dot build voxel. Build voxel. And then we can set the color. And the way I want to set the color is build voxel, comma, or just say color. We build voxel, say, comma, color. Is it colors? I think it's colors. It's colors, yeah. It's colors. We need to import random. And we're going to say colors. And it says random. Colors dot. Colors dot. Random.
Position. This one takes 3 arguments. The position where you want to spawn the voxel, a small solid cube. The color of the cube, this is free in this level, you can choose the color as you like. And whether physics should be simulated or not. Now, if we want to be sure that the blocks stay in place, we should not simulate physics so that they are not affected by gravity. Otherwise, this house could, well, collapse. All right, so the position is simply x, y, z. So this is the position in meters. So the level is designed this way that if you use the coordinates like this, it will, well, spawn at the correct location. You could.
Okay. So voxel then. Alright.
Of course, move the house somewhere else. You could subtract some coordinate here and move it somewhere else. Or you could, instead of building it on the ground, you could also build it up in the air, move it up. This would work as well. Now, color is free. We've really chosen, let's take red. And do not simulate physics.
All right, so we'll say red, and then we'll say random, and then we'll say comma false, and then we'll clean up. Right, so in theory, I now understand this object a little bit more. And I understand how it arrays itself, because this is an alien object. In a coding world, objects, you have to understand them and their abilities. And so we run this bitch and it runs. No, we have a line 22 error. Let me check.
Okay, this should be everything we need. So we do not need a while loop here. We simply need to build this structure once. We need to read the data once, understand it, iterate it, and build. No reason to have any dynamics in this code.
4x, 4y. Oh, I'm stupid. Oh. Alright, there we go. Function is function. Oh. Oh. X, Y, and Z / colors. I didn't like colors. It is not supported between. Oh, yeah. Builder dot build. Yeah. Colors space. Comma. Colors. Random. Does it have to have an argument? Let's just say red. Oh, it's just a capital random. Right. Fixed it. Let's just do this. And let's add a sleep. Um, 0.2 should do it. Wicked. To be at 13. Cool. Or not. So let's find the largest block. Right. So find a box where the player can enter a short text. This sensor is telling me the size. Okay. And the mass. Oh. How high is the largest box? Enter the results into the bitch. Now if I restart this, is it random? It is. Right. Okay. So we're gonna create a loop. Where this guy is going to start plotting data. If the laser is not on the laser, we want to plot data. This is going to be a really cool script. Really cool script. So I'm going to go over the logic. So the logic is the rangefinder, the distance is below 2.6. Sorry, if the distance is beyond, if the distance is above 2.6, okay. If rangefinder scanner if get distance if scanner.getDistance all right, so if scanner we could create a depth. Let's just say depth. Now let's say if scanner let's define. Did he please put a reset in here? No, he didn't. Start from the start. All right. End environment. We're gonna say env equal environment. We'll say sim manager dot first. Right. And we're gonna say scanner. Scanner needs to be called scanner. So we would say scanner equal scanner. Get off of my screen. It's rangefinder, isn't it? Rangefinder. Scanner equal rangefinder dot first. Get off of my screen. First. Okay, now we have the scanner. We have the environment. We're plotting the world. Okay, then we need to get enter text results. Input box, which is going to be iBox equal input box iBox equal. All right. iBox equal input box dot first. Okay. Going to do this in neatness. Delete that. Okay. And we have the mover equal movable platform. Mover equal movable platform dot first. Right. Then we need to reset the sim environment. So we say env after we bind all of our objects, reset, restart. Or it's pause. I always forget that. Restart. Stop. Stop code false. Okay. Right. And we'll just get rid of this because it's pointless to do. Okay. And we're going to space that down. And that's the first part of our script. And it will locate all of the targets. And we'll be okay dokie. Now I saw something here that's important. Inbox set text to some text. So that's going to be important later on down the line. We're going to have to kind of create our code to work properly. code. While true loop here for set the target location. We're gonna set an array. All right, so all right, from numpy import numpy. So we can create kind of coordinates. All right, so we're gonna create coordinates. Coord. All right, from coordinates, we will say set the target location. Right. So we'll just say mover. We already have mover. So we'll say mover. Set target location. How did he set up a numpy array? Just so he said mover. Right, mover. Oh, all right. So we would do np uh all right, so I need to set a interpreter. So for Vox, let's just say gas. let's just say location is equal to, right? We'll say location, enter for location, MP as array, as array, we'll say MP as array, and then we'll set mover, set target location. Set mover to set target location. And then it will print nope, that's not going to work. So what we need to do is we need to set we need to make a loop. Yeah, we don't need an array yet. We need to set the loop. So let's go ahead and set the loop. All right, let's do that. Let me go back to one of my old examples here. Military sniper rifle. Yeah, we'll go here. And this is where one of my loops are that I like. My platform. Not here. Not while sim environment run main get object dust detections. Okay, right there. Get first. Mover equal movable platform first. R equals sniper rifle first. Target locations list. Our target locations are going to be this to this. And we have called to target location. Oh, I can just call to this target location. Do it. And then that's just a while loop. Right here, get object detections. Code. Alright, so here two. And then creative. Puzzles. Find the large block in a row. Alright, and in my loop here, we're gonna just place that there and see what happens. Please work. There's my target locations, and then we're gonna say I guess I'm just gonna say equal to. Let's just say lock equal target locations. And we'll just say no, let's go ahead and then just say mover target. Set target location. Should do it. What are you bitching about, man? Can I import name numpy? Import np from np import numpy. What did he do? Import import np as np. Yeah, now it should shut up. Move will set rotation limit. Set rotation limits to VZ890. Okay, and then let's just say this. Let's just say mover dot target location. Still on Hacker Sim? Moon, no, I'm doing a programming puzzle game. Very different. It's very, very different. It's like Hacker Sim, but like way more real. So yeah. We need to move here to move this. There's different dimensions. Oh. Oh, this will be 0.0.0. Let's say 0.5. Let's say 0.1. You're just not moving at all, are you? Let's try -1. You're not moving. Why are you not moving? Oh, my code is still running. There we go. Set target. All right, let's just do 1. Okay, let's do 2. Let's do 3. Let's do 4. Okay, so that's good. We could just do that. Yeah. We could just do that. That'll be how I do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we just do that. And then we just set that to 0. All right, so we'll say mover, set target location to, let's just get the results here. Let's set the target location to set the target location to this guy. Get rid of movable platform first because we've already called to it, and we're gonna say that 1 0 0. Run it, and it will throw it to 1. Perfect. The script working good. One more time on the test. All right. Okay. After that's done, we will then... Right. We'll then try. We will then try to grab scanner, find range scanner. We will try to get size. Right. We would try to get the size. So that would be under mover scanner equal get size. And it says that we retrieve the sensor program, or we get the size, and the size is 0.5. So we want to get size. Okay. And then we want to put it in array. Okay, that's going to be difficult. Try. Scanner, okay. Try scanner. Try scanner. Dot get size. All right, so get size. All right, and then I could call to the scanner to print get size in an array. But let's just print. Does it have the ability to print? Let me see. A multi-purpose laser scanner. Oh, is it just get? Oh, it's get underscore size. Yeah. Get size. Okay. Let's see if that works. Let's see if that actually gets size. Invalid syntax. A ducky? Let's do elif. And then yeah, yeah. I believe that, yeah, I guess there's nothing very good. Makes my life easier. Uh, but why are you not, getting a size? Okay, so size is 0.5. Get size is not defined. Let's just say get size, then size. Need to figure out what this thing can do. So we gotta go scanner. We're gonna say rangefinder dot burst dot get size dot print. It's not getting the size. And that's pissing me off. You said that you get size. Okay, what if we just print to get size? Let's get rid of this. And then you're gonna print get size. Yeah, I could just say else print. How about that? How about that? How about that? What? Else print. Oh, get size is not a thing. Scanner dot get size. Maybe it just prints it. Maybe its function is to print. Give me an example code. Please, God. Please be something nice. You don't have anything. You're a dick. You know that? You're a dick. I can't get size. It's ticking me off. He has no solution posted. Get size vector 3. Get size of the target. Print rangefinder first. Get size. Thank you. Well, that makes my ass feel a lot better. So it says here print scanner. Okay, so it starts with print. All right, so we're gonna print scanner. Get size. Yes. All right, now I feel so much happy. Okay. Right. So it'll go like this. Mover. Then sorry. Wait. Wait. Okay. Time. Okay. 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 Didn't like that. That's what I had. I didn't like that. Do it. I've never used condition before. What is that?
Certainly. In programming, a condition is a statement that evaluates to either true or false. It's often used in control flow structures like if statements to determine which block of code should be executed based on the result of the evaluation. In Python, conditions can involve various comparison operators, logical operators, and other expressions. Here are some common examples of conditions. 1. Comparison operators. Equal, equals, not equal, t equal, greater than or equal to, equals to, less than or equal to, and 2. Logical operators. And, or, not, not. 3. Other expressions. Membership in, identity is. For example, a condition could be checking if a variable x is greater than 10, Python x equals 15, condition equal x 10. In this case, the condition x10 evaluates to true because 15 is certainly. Let's break down a condition using the expression a plus b. 1. Variables. A and b are variables. They can represent any numeric values or expressions. 2. Expression. The expression a plus b represents the sum of the values of a and b. 3. Condition evaluation. When used as a condition in an if statement or a loop, the condition a plus b is evaluated to determine whether it is true or false. 4. Truth value. If the result of a plus b is non-zero, i.e. not equal to 0, the condition evaluates to true. If the result is 0, the condition evaluates to false. 5. Examples. If a is 3 and b is 5, then a plus b equals 8, which is non-zero, so the condition is true. If a is 0 and b is 5, then a plus b equals 5, which apologies for the confusion. Let's simplify it further. 1. Variables. A and b are like boxes containing numbers. 2. Expression. When we write a plus b, it's like putting the numbers from box A together with the numbers from box B. 3. Condition evaluation. After putting the numbers together, we check if the result is something we like or not. 4. Example. Let's say box A contains 3 and box B contains 5. What is it like when we put them together, a plus b, we get 8. If we're happy with 8, we say the condition is true. If we don't like 8, we say the condition is false. So, in simple terms, a plus b is just adding the numbers from box A and box B together, and then we decide if we like the result or not. In programming, the condition is typically identified within control flow statements, such as if statements, while loops, or other constructs where a decision needs to be made based on whether the condition evaluates to true or false. Let's take the example of an if statement. Python a equals 3, b equals 5. If a plus b 7, print the sum of a and b is greater than 7. Else, print the sum of a and b is not greater than 7. In this example, the condition is a plus b 7. Here's how it's broken down. A plus b adds the values stored in variables a and b. A plus b 7 checks if the sum of a and b is greater than 7. If the condition a plus b 7 evaluates to true, the first print statement is executed. Otherwise, the else block is executed. So the condition is identified within the if statement and is used to control which block of code is executed based on the result of the evaluation. Certainly. Do this, then this in Python can be interpreted as performing two tasks sequentially. Here's a simplified and short example in Python. Python hap do this task 1, then do this task 2. This code snippet simply executes task 1 first, followed by task 2 in Python. In Python, when you write two lines of code, one after the other, they are executed sequentially, not at the same time. This means that the first line of code is executed completely before the second line of code starts executing. For example, consider the following Python code. Python print hello print world. The output of this code will be hello world. The hello is printed first, followed by world, because Python executes the print hello can-like statement first, and then moves on to execute the print world statement. So Python does not do them at the same time. It executes them one after the other in the order they are written in the code.
Executing code at the same time.
It seems like you might be referring to a scenario where it appears Python is executing code at the same time, which could be due to multi-threading or multiprocessing. In Python, you can achieve concurrent execution using multi-threading or multiprocessing libraries. These allow you to run multiple tasks simultaneously, which can give the appearance of code being executed at the same time. Here's a brief explanation of each. Python's threading module allows you to create multiple threads within a single process.
So PyJop is it's basically fucking, because I'm just like confused, because I write in Python all day and literally this is ridiculous. It's literally doing all of this shit at the same time. It's been doing that for the last 6 freaking days I've been playing this PyJob environment. Alright, so I mean I'm not crazy. This is logical to me. This is just it's not working.
In the provided code snippet, it appears that you're trying to perform some actions involving a scanner and a mover object, and you're printing the size of the scanner before and after moving the mover to a new location. If the code is skipping steps, it could be due to a few reasons. 1. Concurrency. If there are multiple threads or processes running concurrently, the execution order of the code may not be as expected. Ensure that there are no other threads or processes modifying the scanner or mover objects concurrently. 2. Synchronization. If there are shared resources being accessed by multiple threads or processes, ensure proper synchronization mechanisms are in place to prevent race conditions. For example, if scanner.getSize or mover.setTargetLocation methods modify shared state, you may need to use locks or other synchronization primitives to ensure consistency. 3. Exception handling. Check if any exceptions are being raised during the execution of scanner.getSize or mover.setTargetLocation. If an exception occurs, it could interrupt the normal flow of execution and lead to unexpected behavior. For logging, consider adding logging statements before and after each step to track the flow of execution and identify any potential issues. Without additional context or error messages, it's challenging to pinpoint the exact reason why steps might be skipped. I'd recommend examining each step carefully, ensuring proper synchronization and exception handling, and
Okay. So he's saying it's PyJob. Alright. Alright, let's use let's do this. Let's do this. Let's go. Let's go here. Then after Mover is movable platform first. And let's import this. And let's go down. And let's get is moving. Bring get is moving. Example, mover, movable platform first if mover get is moving. Print is moving. Return is moving. So there's automatically falses in here. Check whether the platform is currently moving, true or no. Well, print get is moving. Mover first if mover dot get is moving. If mover dot get is moving, then print is moving. Moving. Okay. If mover is true, let's just say false. If moving is false, then we say stopped. That should work. Get is moving, so check whether the platform is currently moving, true or not. Movable platform is mover. If mover is moving, print moving, return. So bool. That's weird. So the get is moving self. The def def is bool, checks if it's true or false or not. So if bool self equal to bool or self greater than or minus is equal to, sorry, Jesus, minus or not greater than bool. Um, check whether, oh, def is get is moving. Um, example mover.
Sure, let's simplify it further. This function checks if a platform is currently moving or not. It tells you whether something is on the move or if it's staying still. When you call this function on a platform object, it gives you a true if the platform is moving and a false if it's not moving. Here's how you might use it. Python mover equals movable platform.first. If mover.get is moving, print the platform is moving. In this example, if the platform mover is moving, it prints the platform is moving. Otherwise, it doesn't print anything.
Okay, so it's else. I figured.
Yes, that's correct. In the code snippet provided, the else block is executed when the condition mover.getIsMoving evaluates to false, indicating that the platform is not moving.
All right. And
Certainly. Let's break it down. Function name, getIsMoving. This is the name of the function. It suggests that the function is used to get information about whether something is moving or not. Parameters. The function takes no explicit parameters apart from self, which is a reference to the object itself, a common convention in Python for methods. Return type, bool. This indicates that the function returns a Boolean value, true or false. This function is likely part of a class, possibly named movable platform. When you call this function on an object of that class, it checks whether the object, presumably representing a moving platform, is currently in motion or not. If the platform is moving, the function returns true. If it's not moving, it returns false. So in simple terms, this function tells you whether a moving platform is currently in motion, true or not, false. Certainly. Let's break it down. Self. In Python, self is a special parameter used in methods within a class. It refers to the current instance of the class. When you call a method on an object, Python automatically passes the object itself as the first argument to the method. By convention, it's named self, but you can actually name it anything you like. Bool. This is a type hint in Python. It's a way to specify the expected type of the return value from the function. Here, mer bool means that the function is expected to return a Boolean value, true or false. This type hint is optional, but can be helpful for clarifying the function's purpose and expected return value. So in simple terms, self indicates that the method operates on the object itself within a class, and merge bool specifies that the function returns a Boolean value.
So why would they do that and versus just create it to return a print statement? That's strange. Strange. Okay. Okay. So now we just we have a Definity. It should not be called to. Yeah, it is moving. All right. Controller, movable platform. Fixed your code for you. Doofus fucker. Thank you. I'll do it. You still define it. Oh. Duh. Okay, the platform is not moving. Alright. Was not connected to the sim environment. Get the fucking class out of here. Go back to a definity and call to the def to give you an answer. And I want to create a class. Yes, that's what I wanted the whole goddamn time. And then we need to connect to the sim environment first. Before that. After import. Only after import. No, you dumbass. Yeah. No, there's no, only after import. Yep, that is correct. Okay. And then we disconnect. Right. Correct. All right. Right. So the platform is not moving. Call to Dfinity. Smarter, better way to do that. Right. All right. Okay. Okay. All right. So on our loop here, we're going to add to def get is moving. And we're going to make sure that we get is moving. Okay. And now this is important. If we are okay, if we are moving, then we move to location. If we are moving, we wait until we are moving. Like this. All right, so you said that if the size of the scanner before moving, mover platform first. If mover is not moving. No, just this block. Mhm. Thank you. Finally. No, no, no. Assuming. Assuming I already have the rest of the code, just that block, please. Okay. Just edit this block. Bro, what are you doing? Move, get is moving. If move, get is moving. If move, get is moving. Print platform is moving. Wait until. Okay. As a look. Yeah, you apologize. You better. Okay. Just this block. Don't combine. Thank you. Always trying to combine everything. Stop it. Platform moving. Wait till it stops. While mover is moving. Time sleep. Scan get size. If mover get is moving. I like that now. That's something. If mover get is moving. If get is moving. Yes. If mover get is moving. Print the platform is moving. Wait until it stops. While mover get is moving. Okay. All right. Okay. Okay. Good. Moving logic. Okay. But right. But if print, right? But if print platform is not moving, wait until print. I'm confusing myself. If mover get is moving, the platform is moving, wait until it stops. Do I like that? Do I accept that? If mover is getting moving, so I'm gonna move and then I'm gonna stop. So I'm gonna walk, and if I'm walking and I get is moving and the platform is moving, I do not scan. I do not scan. I do not scan. I do not scan. Right. I do not. I do not print. I do not print. Okay, yeah. I do not print scanner size. Alright, I do not. Okay, so, okay, good. Moving logic is good. Is it good, though? If mover is get is moving, print. Okay, so we don't need to print statement. We don't need to print statement. If, okay, so if bool returns the platform is moving, if the plat is moving, we do not print scanner size. Logic is hard in programming. We do not print scanner size until bool return print platform is not until bool return. We do not print scanner size until then we print scanner size. Now that's a complicated ass thingy. Okay, if mover is moving while mover is get moving times sleep, print the platform is not moving. Print scanner size. Alright, so print scanner size. Print scanner size. If mover then set target to 1.00 and we print scanner size. Okay. Let's test that out. Did it again. Oh, fuck. Oh, yeah. There, go that. That'll do it. Hmm. This is a step. This okay. Let's a while loop that. While loop it. Uh-huh. Alright, and then
Thank you for the follow. Smithin is always glad to see a new face.
thanks for the follow. Um Ezir, thank you. Remove this. Thank you. Clean it up. Alright, so that's not a loop. Yes, it is. Okay. I'm not playing Anonymous Hacker Simulator right now. I am playing another game. Like it. It's a programming puzzle game for programmers. It's really difficult. It has a scoreboard and it's really, really intense. Really intense. And you basically make robots that do certain things. And you use Python in programming to do it. Um, move, get, size, print, get size, move, get size. Hmm. 1/0. Okay, no problem. Have a good one, dude. 1/0 should go every loop to 2/0/0 3, 0, 0. There you go. Okay, that's a great loop right there. And now it should do it. Hmm. So it said here that current location equal mover. Wow, did you remove the depth? Yeah. Here's the whole script. It's your error. Yeah. You forgot the depth. Oh, you think it still works? You're mistaken. Movable platform object on 26. It's get target location, dumbass. Okay, so see what I fixed. Uh-huh. Okay, and you also fucked up on lock. His location is not defined. So let's define it. Where did you fuck up? Missing one required argument? What line is that? 26. This is the art. Alright. This is how we get. Yeah. That is how we get is moving. You understand? Good. Mover equal movable platform. Right. You understand? Good. So, what the fuck is luck? So, what the fuck is this? No, no, you can't do that. You can't do that. It's impossible. Line 26 is missing an additional argument. Lock. Right. Okay. Uh, oh, yeah, that's right. Current location mover. Get the current location. Why do you need the current location? Yeah, okay, so write the code. Right. So your print statements were fucked up. The whole thing. Oh my gosh. The whole thing. You really. really, really are good at pissing me off. Dude! Get it right, bro. Yes. Alright, so we printed current location. Oh man, you are alright, fixed it. Okay. Now the loop needs to do this. scanner, get size. Print. Wait, did I define get size? Print get size. Then move. One, zero, zero. Then print get size. And move 2, 0, 0. And get size. Three. And we're gonna go down from 10. This loop will move the platform coordinate from 1 to 10, printing the size before each move. It will reverse it again. Alright, mover set target location 0, 0. Okay, but when does it get size? Get size. Alright. Well, get is moving. Needs to get this size once. Beast. Disconnected. Yes. Found the error. Hmm. Run it again. .75 is the highest number. What I want to do That literally took me 6 hours. like that mission took me 6 hours to code. That's what I'm saying when this game is really fucking hard. I'm gonna go to bed. 6 hours. 6 hours. Good night. See you tomorrow. Peace. I want to give a shout out to everybody who followed me here. Ezir, Port, Ben, Darkfear, and if I didn't say your name, thank you. And y'all have a good night, morning, and afternoon.